Good morning, everyone. Hello, good morning, good morning. All right, I hope I'm audible, visible to everyone. Just cross confirmation. Awesome. Just a moment. Cool. Let's wait for one more minute and then we'll get started. Am I not visible? We are not able to see you, Cam, while. Okay, so I already turned off that video. Yeah, I'm visible. Okay. Cool. Also, meanwhile, I'm expecting that all of you were able to access the content which I shared, including the uh, quiz, assignment, notes, PPTs, whatever that was. So I hope you all were able to access it and you are not having any issues with that one. And regarding the assignment deadline, it is expected to submit the assignment by the next week. So 1 week is the deadline for all of the assignments. So let's say today I have given you some sort of assignment. Then after 7 days, these 7 days is the deadline for it. So you need to cover it before the next class, right? That's the simple thing we will be following for all the assignments. Challenges team is working on it because we all need to onboard you for the challenges part, and we are putting some challenges there, so you will be able to do it. We will keep you posted in the Discord once it is done. And yeah, I guess this thing we already have put a note for that one, because in the assignment or probably in the quizzes sometimes, right, you will find, you may find as well few topics which are probably not taught in the current class or something. So that is what you can ignore for that time being. And once that topic is covered, you can again come back and you can cover it, right? So no, nothing to worry about it, that if topic is not taught and not include and questions are included in the assignment, so probably we will be missing this topic or something. Okay. And once we will be finishing up the last class of SQL, after that, I will be giving you a lots of interview questions and cheat sheets as well and proper guide. So that will be after the last class of the SQL, nothing in between. Okay. Cool. Let's get started with today's agenda. So we'll be continuing that part where we left yesterday. And one more thing I would like to tell you, because I want all of you to be ready with that one. So starting from Hive, right, the module which we have for Hive, we will be setting up the things on the GCP cloud, right? The Dataproc cluster, all those things, manage Hadoop basically. Okay. So for that one, or in order to set up the free tier GCP account, I will provide the links as well in the pre-read. You can see the setup, but don't set up anything now, right? When I will tell you, but few things which are required for it, your debit or credit card, right? And international payment should be properly enabled for that one. And all the address related details should be verified. So you still have enough runway, like two weeks almost. So anyone who don't have that debit card, credit card with international payment available, so please make sure you do that. Okay, now let's get started. I'm going to share my screen. And if anyone is having doubt GCP, where we are having GCP, where we are having Azure, so feels like you still haven't looked at the curriculum particularly, that what we are doing and what platform, what lab, what cloud we will be using for which particular module. So spend some time with the curriculum, have a look at it. I'm not expecting these type of questions in the classes. Okay, so let's get started. Cool. I hope my screen is visible to all of you. Okay, so till yesterday we touched upon the integrity constraint part. That was the last thing. So now we will look into the few more DDL related commands. DDL related commands, basically those type of SQL commands which puts some sort of direct impact on the structure of the table. Okay, so there we discuss create command. And now imagine a situation where you have created a particular table, and what you want to do, you want to make some changes in the structure, right? Maybe deleting a particular column and in future adding a new column. And let's say there was a column XYZ and earlier it was of string type, and maybe at later point of time you want to change its length. Earlier it was only accepting the 20 characters. Now let's say it has to accept the 50 characters something. Okay, so if that is the scenario, then how we will be doing it? So for that one, we will be looking at the alter command, right? So alter is also something which falls under the DDL because it will be altering the structure of the table. Okay. So let's quickly first create the database and table and insert a record into it. And then we will look at the right. So here, these are the commands I will be executing one by one. So first, what I'm doing, you can see this SQL command. We are creating a database named as class2 underscore DB. Okay. So let's say this is the database I want to create. So I have executed only this specific command, right? Sometimes I have seen people making this mistake. Let's say they have copy pasted 5, 6 commands here, you can say on the terminal. And after that, maybe by selecting all, you can do this, right? You can just simply select on and you can click on this thunder sign and everything will get executed sequentially. But let's say if something few table is not created or any command there, then there are possibilities that you are getting some errors and then people start getting confused why I'm getting this error, that error. So if you are following step-by-step process, so just select that particular SQL command which you want to execute. Just select it completely and then click on this thunder sign, right? So I have created this database and it is still not reflecting on the left hand side. So I will just refresh it. Now you can see class2 underscore DB is created. And now I want to go inside this particular database, right? I want to use it so that I can create tables inside that one. So I will simply select and run this one. So use database name means we are inside this particular database currently. Okay. Now what we want to do, we want to create the table. So here you can see we are creating an employee table, ID, name, address, and city. Okay. So let's click in this one and our table is created. You can see at the bottom, this option, this action is successful. And yesterday we also looked at the insert command, means how to add the entries or how to add rows in the table. So for that one, we have this insert command. And if I select this one and execute it, so you can see data is inserted. And now we would like to verify whether data is inserted properly or not. So we can simply run the select command, and you can see this is the select output we are getting, and this is the DQL, data query language, means we are trying to query the data which we have in the table. So you can see one record we are getting in the output. Okay, so that is our basic setup. And next thing which we want to do first, so this is the table which we have created, and maybe let's say in future uh, we want to add a new column, for an example, date of birth. Okay, so in order to add a new column, how to do that, right? What we can do here. So for that one, we need to follow this syntax, right? Which particular alter command we will be following? This one, right? And the use case is we want to add a new column in our uh, just oh wait, yeah, we want to add a new column. So for this one, we have this alter command, right? So this syntax, add a new column named date of birth in this table. So the syntax of alter is going to be pretty much simple, and this is something we will be using for changing the structure. Means we will be looking at all the syntaxes, right? Even the renaming of a column, modifications, and let's say we want to add some constraint at the later point of time, and let's say removing a particular constraint, then how that can be done with the help of alter command, we will be looking into it. Okay, so here the syntax is pretty much simple: alter, table, these keywords are needed, and then table name. So after this part, you need to mention what kind of operation you want to do, right? It could be adding a new column. It could be renaming any existing column. It could be deleting a particular column. So we'll look at it one by one. So here, first, we want to add a new column. So alter table, table name. This table we want to alter. What we want to do, we want to add a new column. So add keyword, and that's new column name, which is DOB, date of birth. And since it's a new column, we need to provide the data type of it. So we would like to keep it as a date. So this is going to be our syntax here. So let's select it and execute it. So here we can see the particular action is successful. Now, my quick question to all of you: earlier we created this table with 4 columns and we inserted this record as well, right? And now, since we have added a new column, date of birth, so in that case, what will happen to this existing record, right? What will happen to this existing record? What value will be there? Correct, right? It will be having a null value because that is our existing table. We added a new column and without any value or something. So, and even with the alter command, right? You won't be able to pass any specific value that, okay, I want to pass this DOB with this particular value. If you want to do it, right? So first you need to add that column, and then you need to run some update query, which we will see later, that how to update some specific records or specific value. With the help of update query, you need to add some value in this column, right? So let's verify this one as well, that what is there. So let's run the select command. And now you can see, as soon as I run the select command, so you all were correct. So you can see DOB column, but with a null value. Okay. So this was the syntax. This is the syntax of alter you can follow to add a particular new column. Now let's look at the, you can say, another variation of alter, where let's say we want to change the data type, right? We want to change the data type of the existing column. Okay. So here, let's say the name column, you can see, right? Name column, earlier it was having the, it was at max accepting the 50 characters. Now we want to modify its data type, and we want to basically change it in such a way so that it can accept the, you can say, accept the 100 characters. Okay. So quickly, how we can verify this one, right? Maybe after making these changes, how we will be able to verify it. So for that one, what I'm going to do, I am going to run this show create table command, right? Yesterday we looked into it as well. So show create table for this particular table. So with this one, we will be getting the create table statement, right? So why I have executed this command so that we can verify after making this change, right? Whether the actually the definition of the table is getting changed or not. So if you look at the create table command, you will see, right, at this moment name, and I have highlighted it here. Font could be a bit small because can't be increased from here much, already on the 100% side, I believe, or no, it is increasing the font of this one. Okay, so here you can see name varchar 50. Okay, so let's run the modify alter command. What is the syntax for this one? All right, so this is how the syntax is gonna look like. Okay, alter table, this is the common syntax, right? This part is going to be common for all your alter operations. So alter table, table name, right? After that, these things can get changed. So here we've added a new column, and now what we want to do here, we want to modify the existing column, right? So here the keywords will be like this: modify column, right? And which column? So column named was the column's name was name itself, right? So name column we want to modify, and here what you need to do, you need to provide the new data type of it, and that new data type is varchar 100. So we are changing the data type of the particular column, right, with the help of alter command. So here let's run this alter command, and after that we will again run this show create table to verify whether the table structure has been changed or not. Or we can even we will try to see from here itself if we can. Okay, let me refresh it. So tables, employees, columns. Right. So here it does not show you the data type of it, but that is fine. We will see it from here. So let's run it. So cool. This alter operation is also executed. Now let me again run this show create table command to see the table structure of it. Now you can see when I ran this show create table command, and in the updated part, you can see name varchar is 100 now. In earlier show create table, it was 50. So with the help of alter modify, we were able to change the data type of this particular column. Cool. Now let's look at the third variation of it, right? And that third variation is if we have this thing. For an example, if we have a use case where we want to change the name of a particular column, right? Sorry, that is not the case right now. Let's say we have an existing column which we want to drop. Okay, we don't want it moving forward. Hence, we would like to delete that column because it is quite unnecessary for us and maybe occupying and unnecessary. If we are keeping it, it is occupying unnecessary space as well. So we would like to delete that particular column. Okay. So right now, let's say if I run the select command, so you will see how many columns we have. So you can see ID, name, address, city, DOB. These are the 5 columns we have. Okay. And now what we want, let's say we want to delete or we basically want to delete this particular city column. Okay. So we can use the alter command for that. And the syntax is going to look like this. So again, the first part is again very similar to previous one, like alter table, table name. And then what action we want to perform? We want to delete the existing column. So here, in order to delete delete, what you need to do, basically you are dropping that column from the existing table. So drop column keyword, and then you need to mention which column you want to drop. Okay. So here we want to drop the city column. So let's select this one, execute it. And here you can see this action is executed. And if I again run the select command, I have executed it. Now in your final output, you can see ID, name, address, and DOB. There is no city column now, right? So in this way, we can simply delete our entire column. Okay, and now let's look at this part. For an example, this thing. Let's say now another variation of alter is where we want to change the name of any existing column, right? So here the name column, right? Name column is something, let's say we want to change the name of it. So for that one, what kind of syntax of alter we can follow, right? So rename the column name to full name, right? So alter table employee. This is going to be our main keyword. Then what we want to do, we want to rename the column, right? We want to rename the column. And after that one, you need to provide the old name to new name. So this was our old name, right? And full underscore name is going to be our new name, right? So now if I execute it, right? And now if I again run this select command, so here now in the output of this table, you can see it is ID, full underscore name, address, and date of birth, right? So with the help of this alter command, we were able to change the name of the existing column as well, right? All right. So fine, just okay. So now let's move forward, and here what we want to do, we want to basically we would like to see a difference between two things. So far we have covered the create command, alter command, which are related to your and still in the alter part, we would like to see that how we can add the constraints as well, right? How we can work with the constraints with the help of alter command. So before explaining that, let's look at one and two more DDL commands which directly impacts the you can say which can directly impact your tables, right? So for that one, we have the drop command, okay, and we have the uh, truncate command, we have the delete commands, okay. So this is what we will look at, the difference between the drop and truncate, right? And even the difference between the delete. So this is something which is very important to understand. Let's say you have created a table, right? And after that, when you have inserted some data, you want to delete the data, right? So deleting the data can have different variations as well, right? So first variation could be, let's say you have a table, you have some data inside that one, okay, and you want to eliminate that table completely. Eliminating that table completely, what means you would like to delete the data inside that table, and on top of it you would like to delete the definition of that table itself. Definition means the entire structure of it. Okay. So here, let's say as soon as we created the table, right? And if I run the select command, so what I will be getting, I will be getting the output without any rows, correct? So that means it is our empty table, but it has some sort of structure, right? And that is why when we ran the show create table command, we were getting some output as well, that, okay, this is the create table command of this particular table. But with the drop command, right? So we have the drop command, and it does the same thing, right? It will delete all the data which you have inside the table, and on top of it, it will just delete the definition of your table as well. That is first thing. And I will show you a difference as well. We will talk about few more differentiating point between these things. And second is truncate, right? So truncate command. So let's say you have a use case where you only want to delete the data, but you don't want to delete the structure of that table, right? So in that case, what will happen? You need to, in that case, you basically need to uh, run the truncate command, because truncate command only deletes the data and does not delete the structure of the table. There is third thing, the delete operation as well, delete query. So delete query is basically for those use cases where you want to do the selective delete based on some condition, right? Maybe you have a data for 10 countries in your table, and you want to maybe delete the data for some country XYZ, right? All the records where the country name is XYZ, you want to delete all such type of records from the table, right? Then delete command will come into the picture, because it helps you to do the selective delete. And let's try to understand few more differences between these, right? So this is the syntax I was talking about for delete command, right? So let's say you want to do the delete, and we will look at the where clause, how it works, all these conditions we will be looking at. But here, just you can understand it, that how it is working and how its basic syntax look like, right? So here, I hope you all are able to see this part. So here we will be discussing few differences, because this is one of your important interview question as well. So directly as a ice breaking question, interviewer may ask you difference between drop and truncate, which is a much more common interview question. But apart from that, somebody can ask like all three: drop versus truncate versus delete. Okay. So let's look at it one by one. The main purpose of drop, you can see, completely remove the entire table structure from the database. Truncate, remove all rows from a table, but the table structure remains as it is. Delete, removes specific rows based on a condition, or all rows from a table, but the table structure remains same. That is the purpose. Now the transaction control. So this is also very important part, right? And when the interviewer is asking this different question, so he is expecting two answers from your side for sure, like two mandatory answers. One answer you need to give with respect to the transaction control, and second answer you need to give with respect to the performance and the space removal, right? Apart from that, whatever differentiations you are giving, that is very basic, very common, and most of the people knows about it. But with respect to the transaction control, space and speed, right? So these will be the three differentiating point which interviewer is expecting from your side. So transaction control means if you have executed the drop query, if you have executed the drop command, that is why this is just like a nightmare for anyone. And mostly you will see that only admins will have the permissions for the drop command, right? If in a team there are few developers, then you will see the XYZ developers, with the help of grant command, they will only get permissions for few operations like select, insert, update, etc, but nothing related to delete, drop, or truncate, right? Because it can just terminate all the data, right? So this has to be used very, very carefully. So transaction control means cannot be rolled back, right? So if you have executed the drop command even by mistake, no chances to get your data back, right? So cannot be rolled back. Truncate command, right? So same applies here. It cannot be rolled back if you have executed. Okay. Now coming to the delete part. This is interesting because delete is just like your other normal data manipulation operations, like your insert and update. So when we were inserting, right, then we had to commit. Here the auto commit is enabled in the workbench, but manually you have to commit. Similarly, if you want to update something, you need to commit. And delete is also like that, because delete will try to perform all these actions on a transaction basis. And when you do the things based on the transactions, all these things will be written in the logs, right? Your write ahead logs. And once things are there in the write ahead logs, so by any chance, if you have executed the truncate command and you have not ran the commit command, then definitely you can put a rollback statement and all the changes will go to the previous consistent state, right? That is why delete is something which can be rolled back, but rest, drop and truncate cannot be. Okay. Now coming to the space reclaiming, or your question could be like, okay, we are running the drop, truncate or delete. And even before that, when you were inserting the data, and when you insert the data, obviously that data will get stored in the memory blocks, right? So now when we are dropping the table or something, entire data is going away, table structure is going away. So obviously there should be an impact on the available memory or available storage part of the database, right? So when you run the drop command, what happens? It frees up all the space acquired by that particular table and the data which was stored in that table, right? It will free up all that space so that it can be used by others. Coming to the truncate command. So truncate command, it does not free up the space immediately, right? It does not free up the space immediately, but it will definitely clean up all the, you can say attached, for an example, triggers, attached data pages, indexings, all those things, it will free up as soon as you run the truncate command, right? And after some time behind the scenes, what happens? Your SQL engine, your database internal mechanism keeps on running the shrink table sort of operations behind the scenes, right? So in that case, after longer time, when it is seen that, because we have not deleted the structure of the table, right? We have not deleted the structure of the table. Once you run the truncate command, your data will go away. So anything, any space which is required for the table structure, it will be there. For the data which we have removed, right, after running the truncate command, for that one itself, immediately it will not free up the space. Behind the scenes, some sync operations will start executing, and that will basically free up that space. But as soon as you run the truncate command, it will definitely remove the occupied storage by the indexes, triggers. Apart from that, the data pages, all those things, it will clean up. Now coming to the delete command. So delete command, what it does not free up the spaces, like whatever data you had in the table. As soon as you run the delete command, right, it will not free up those memory blocks where that data was stored, right? It will not do it immediately, right? And again, behind the scenes, database will be running these table shrink operations. And when it feels that after a particular time that this space is not going to be utilized, right, for any other data storage for that particular table, then it will free up those memory blocks, and that available space can be used by some other table to store that data, right? So this is the main space related difference between these three and transaction level. Speed is also very important part. So here drop, right? This is definitely fast. So fastest as it removes all the data and structure. Okay. So very quickly, fast, then this truncate and delete. Now for the truncate part. So the truncate command is something which is faster than the delete operation. faster than delete as it does not log individual row deletion. This is important point you need to understand, right? So truncate, as soon as you run it, it is not as fast as drop because truncate has to only remove all the data, but it has not to do anything with the table structure or something. Okay. So it had to maintain that. Hence, truncate is bit slower than drop, but it is faster than delete. Why? For that one, this part, transaction controls answers this question. So delete is like another type of your DML, correct? So you can commit, you can roll back. And when you are doing so, when you basically run a delete command, since it is capable of rolling back and committing as well, that means it is maintaining all the logs in the write ahead logs, right? Whatever delete related references and the plan, all those things are going to be stored in the write ahead logs. Means when you run the delete query, it has some more extra overhead of maintaining the logs. That is the reason the delete operation is something which is the slowest one. The delete operation is something which is the slowest one. Truncate is something which is bit faster than the delete, and drop is something which is much more faster because it is removing all the data, right? Now we will talk about the referential integrity in some time. Then you will be able to understand about these points as well. So for now, just park this one. Okay. Now, where clause. So as I said, for the delete operation, and I showed you the syntax as well. So delete operation, right? If you delete operation is something where you will be having the flexibility to use the where condition, right? Means the filter condition. So selective delete can be done, but with truncate, right? With truncate and drop, it is deleting everything. Hence, it does not support any filter condition. So you can see not applicable, not applicable, where clause is applicable in the delete statement. And which category for these commands? So drop will be in the DDL, truncate will be in the DDL, and delete is in the DML. Okay. So let's quickly run this one. This is what I wanted to show you and talk about as well. So for that one, what is the syntax for the truncate? So let me show you and let's execute that one. So truncate table employee, right? So this is going to be your syntax. So now if I run this one, right? If I execute this one, and after this one, if I run the select query, right, will I be getting some sort of output or not? Or I will be getting some error? Right? So let's execute it, truncate table employee. So let's execute it. And here you can see at the bottom, truncate table employee it is successful. Now I'm going to run the select command here. So select star from employee. So now you can see here, we are like all the records have been deleted from this table, but still you can see the output with the ID, full name, address, date of birth, right? Means a structure is there, but only the data has been removed. We can also run this one, show create table. So when you run the show create table, you can see you are getting some output that yes, create table command, and this is something which exists, right? So now on the other hand, uh, let's say we have this table. Now, if we simply run the drop command, so drop table name. So assuming, let's say we don't have an empty employee table, it is having the 100 records, right? So now if you just simply run this one, drop table name, let's run it. So this is successful. Now if I run the select query, right? After running the drop command, now if I run the select query, let's see what will happen. So I have executed it. At the bottom, you can see it is throwing the error. So let me show you the error. You can see, right? Class 2db dot employee does not exist. Means data it has definitely removed, but it has also deleted the structure of the table. That is why we are not able to find it, right? Even if you try to run the show create table command on top of it, it will give you the same error. Table does not exist, right? So I hope with this one, you are able to see the difference between the drop and truncate. All right, so let's move forward and let's continue our discussion for the alter command. And now how we can use the alter with respect to the integrity constraints. So here, what I am going to do, I am again going to recreate the employee table in the same database, but with a few more columns. So ID, int, name, age, hiring date, salary, city. So right now in this table definition, you can see that we have not applied any integrity constraint. It is very simple and only containing, and even by default, everything is allowing the null values as well. So no any dedicated or specific integrity constraint. So let's execute it. So our table is created, and now what we want to do, we want to just insert some records into it. Okay. So I have these insert commands with me, and I will be running all of them at once. So you can see these are the 5 records. Basically, I'm trying to insert in this particular employee table, right? So let me run this, all the insert commands. So you can see one by one, all these insert commands have been executed, correct? Let's quickly run the select as well. Select star from employee. Okay, you can see all these records are there. Cool. Now, let's say after some time, we basically realize that we want to add the integrity constraint. When we created the table structure, that time we did not add it. Okay. And now what we want to do, we would like to add the unique integrity constraint. Okay. So let's try to do that. How we can do it with the help of alter command, right? Any integrity constraint we want to add at the later point of time. So the syntax is going to be like this. Okay. So here, what we are trying to do, add unique integrity constraint on the ID column. So we have the ID column here, and we want to add the integrity constraint on top of this column, right? So the syntax, this is going to be again common, alter table, table name. After that, add keyword. This time what we want to add, instead of column, we want to add a constraint. So constraint keyword. And then what we need to provide? We need to provide the name for our constraint, right? We want to provide a name for that constraint, and the name is ID underscore unique. This is the name for that integrity constraint we have given. And after that, what is going to be our constraint? Unique ID, right? So this is the constraint we want to apply. So let's run this one, execute it. So this is done. Alter command successfully executed. Let's try to test this one. Okay. So let's try to test it with a new record. So here you can see earlier I inserted 5 records where ID was 1, 2, 3, 5, 6. And here insert into employee values, and I'm trying to insert a duplicate value, then some name, something, something. So let's try to execute it. So now you can see this insert is failing, and let me show you the error. So here you can see duplicate entry 1 for key employee ID dot ID unique. So this ID unique was the constraint name we created for this integrity constraint. So you can see earlier there was no integrity constraint, but with the help of the alter command, we can even add the integrity constraint at the later point of time as well, right? So that is about adding a new constraint. Now, let's say we have added this integrity constraint, right? And maybe when you created the particular table, that time you applied some sort of constraint on top of it, right? And maybe after 1 month or so, you realize that we don't need this constraint and we should simply delete that one, right? So in that case, what we can do, we can simply drop any existing constraint which we have created, right? So how to drop that one? The syntax will be like this. So alter table employee. What we want to do, we want to delete the specific constraint. So drop what we want to drop constraint, and then we need to provide the constraint name, right? So if we execute it right now, if I try to run this command, what will happen in this case? It will fail or it will succeed. The same insert command, if I try to run it. Right? It will succeed because we have removed the integrity constraint of unique check. Okay. So ideally, if we run this insert command, so you can see at the bottom, this insertion has been successfully done because we have removed the integrity constraints with the help of the drop constraint with the help of alter. Okay. So cool. Now, before coming to the next part, let's talk a bit about the primary key and foreign key concept, which is very, very important even for your interviews. Okay. And even for your, whenever you are doing the data modeling, when you are basically designing the data warehouses and you are optimizing the data model and with the by following the normalization forms or anything, and whenever you are working with the complex queries where you have to work with the two data sets, right, joining them, etc., etc. So that is how the concept of keys is going to play a very, very important role, right? So here we will be looking at this part, that what is primary key, what is foreign key, and what is the difference between them, and how to implement that one, right? And what is the main purpose of it. So this is what we will be looking at. So here, first, let's talk about the primary key. And yesterday as well, we talked about it, right? Yesterday, we also talked about it. Okay. So primary key, right? Basically, any column in your data set, right? Any column in your data set, or not always single column, but even the set of columns, right? So for the simplicity, try to put it in this way, that if there is any column in the table which helps you to uniquely identify a record, right? Uniquely identify means that column will contain such type of values that it is different for every individual row in the table. So that column is something we can consider it for the, you can say, primary key. Okay. So as per the definitions, and even you can see in this example itself, that here roll number is something which is uniquely identify every individual record in this table. Because if I call roll number 101, it will always and always give me record for name X. Similarly, roll number 102, it will always give me the record for Y, right? So this roll number values is something which is uniquely identifying individual record from the table. All right. Now, second part is immutable. Primary keys should not be changed once set. That is true, right? When you are creating a particular table structure and that time like you have decided, okay, this is the column which we will be considering and keeping it as a primary key, because these are very important things, and having the primary keys and foreign keys is a very crucial step of your optimized data model. That is why these things has to be identified in the very beginning whenever you are even creating the blueprint of your data model, that okay, I have the database for the Swiggy or Zomato or Walmart or Amazon, so it can have like different type of tables: customer table, payments table, orders table, order returns table, right, and many others. So in that process itself, you need to identify, you need to define these type of columns, that for this particular table, which column should be, or which column we should have like a primary key, and how to generate values in this one so that always uh, it always remains like a primary key, because this is the main uh, you can say point about the primary key, that it cannot have the duplicate values, because it will have, if it starts having the duplicate values, right, then it is not solving our purpose. Means it is not solving the uniqueness kind of purpose, because there are two records which are giving different values but having the same primary key. Okay, so that is something which becomes very important here. And next is the immutable part, which we talked about. It should not be changed. Ideal to keep primary key as a simple as possible, right? Any column which is easy, and obviously having the distinct columns, right? Here, they should not contain meaningful information, right? So what is the main purpose of it? Like, you cannot always, or you should not go for any such column which contains some kind of meaningful information of use, right? Ideally, you will see IDs kind of thing, or the auto incremented numbers or something is something which we will be using for the primary key. For an example, if you are thinking, okay, can I use name as my primary key column? Obviously, it's a bad idea, because two persons might have a same name. Similarly, if you are thinking, okay, I want to use the salary column. So similarly, salary can be also duplicated. Plus, salary is something which is a meaningful information for you, right? Which you might want to analyze later. But that is not a good fit, or good, like that is not a candidate to become the primary key because of multiple reasons, right? Indexing, this is the concept of the optimization, right? And we will look at it in the later part of our module of SQL, that how to create a index, what is the meaning of it. So this is more on the optimization purpose. So right now, like you can just park this point, that what is indexing. For simplicity, just understand it. It is for the optimization, so that query results can be much more faster, because it will be able to read and write the data much more faster, right? So this is for that one. Referential integrity, this is related to foreign key. We will talk about it, right? And the data types, what kind of columns we should actually pick, right? What kind of columns we should actually pick, and what kind of data types they have. So usually any ID column, which you will see that only containing the ID integer kind of values, or if there is some alphanumeric kind of column, right? So that is also something which can be, that type of column can be used if it is distinct, right, and not having the duplicate value. So in that case, its data type is going to be string, right? So yesterday we talked about this one important interview question as well, that what is the difference between the, you can say, difference between the unique and the primary key. So the main difference is both of them, right, primary key and unique, both of them, right, keeps the distinct values. They does not allow any kind of duplicate value, but unique can contain one null value. Primary key, on the other hand, cannot accept any null value. This is the main core difference between these two. Okay, now quickly talking about the concept of the foreign key, right? So let me help you to understand with this one. Just a moment. All right, so let me show you. Mhm. So we'll try to understand it with a very basic example. So for an example of this one, so let's talk about the primary key. Okay, so here, let's say we have this table. We have two tables basically. So this table is, let's say, ID, ID and employee name and department ID basically, right? And our table name is employee. Okay. And we have this one more table, department. Okay. And it is having, let's say, two columns, department ID, right? And maybe ID and department name. So 101, 102, 103. So here, let's say HR department, IT department, and finance department. Okay, and here, assume you have the employee ID A1, A2, A3, and name is X, Y, Z, and then let's say 102, 101, 102. Okay. So if you look at these two tables right here, so these are two individual tables, right? So there are two individual tables, and here what we can say that in this employee table, right here, ID is the primary key, right? And in this table, what we have again the ID is the primary key. But in these two tables, both of the ID column have the different meaning. These two, this ID column don't have any relation with each other, right? Because if you look at it, this part, right? So this one, just a moment. Yeah. So this one, this ID column and this ID column, right? These three ID columns, they have nothing to do with these three, right? But if you look at
this particular column, if you look at this particular table, here, this ID column basically representing the unique IDs which we have generated for the different department names. And here, these are the unique, you can say, values which are of alphanumeric like A1, A2, A3. These are unique in these three records. So this is what we have generated, and it is a distinct value. Hence, we are calling it as a primary key. And this value is representing the employee ID. And this value is representing the department ID. So here ID is primary key, here ID is primary key, right? But here what we can say that, right? So this one, the department ID. In this table, department ID is basically your foreign key, right? So foreigner, like this is a very similar term. So how you can put it? So let's say you are an Indian, right? And you are visiting a different company, right? So in India, you are having an Aadhaar number, right? Each individual person having one unique identity, which is your Aadhaar number, right? Similarly, if you are in US, like you will be having the SSN number, which is a unique ID number for individual person staying at the USA. So for us, let's say, right, we are in India, and you can treat yourself as a primary key of the India because you are the member of the India itself, and uniquely you can be identified. Correct. Similarly, imagine yourself, you from like outside India, you can go to different countries, and where you will be treated like a foreigner. Okay. So here, right, in this example, what I'm trying to highlight basically, this ID column is a primary key. So main technical definition of foreign key, any column which is a primary key of another table and is getting referenced in this particular different table, that column will be known as a foreign key. So in this column, if you look at this structure, I have one different column named as department ID. And where you can see we are putting the values 102, 101, 102, right? So you can see these values are somehow matching with this one, right? These values are matching with this one. But when we are creating the table, how to set up this integration? Because let's say, since this table data is visible to us, only then we are able to identify, okay, seems like department IDs values are coming from this ID column of department column, right? But how to set up this kind of integrity between these two tables, right? Because imagine if this department table does not exist, then how you are bringing this 102, 101, 102 values, right? Because you don't know that these type of values will even exist in department table or not. So this is the integrity, means until unless some value exists in department table, right? And if we are trying to refer it in this particular table, then it should definitely throw the error, because this value, right? Maybe for an example, here I'm trying to replace it 104, which does not exist in this department table, right? So obviously we need to maintain that kind of referential integrity. This ID column is a reference in this table, right? That means we have to maintain this tightly coupled referential integrity. So here, these two things like the primary key and foreign key, right? Foreign key means any primary key column of a table which is getting referenced in a different table will be known as the foreign key. So now let's look at it. So here now the things which I simply explained you. So referential integrity, foreign keys link records between tables, maintaining data consistency. So the example I was showing you, so you can see if this kind of tightly coupled integrity is maintained, so there will be no data discrepancy. Data discrepancy means, again, 104, which was not present in the department table, but we have used some value in the employee table, which will definitely creating some data discrepancy. Next, nullable. Foreign key can contain null values unless specifically restricted. So again, what we actually mean with this point, foreign key. So here in this employee table, right, this department ID column is referring to this one, right? And similarly, you can see this can be repeated 102, 102. I have repeated twice because department ID column in this table is a foreign key. It is not a primary key, right? So here, if I am keeping department ID as a foreign key, so I can even put a duplicate values and I can even put the null values here because this is not the primary key of this particular table, right? This is the foreign key, but here it is the primary key. So obviously it has to follow the rules of no duplicate values plus no null values. So this is what this point is all about. Match primary keys. So each foreign key must match a primary key value in the parent table or be null, right? For the constraint I was talking about. Ensures relationship. They define the relationship between tables in the databases. This is the main part I was also highlighting, that related to your data modeling. Whenever you are doing the data modeling, so these type of foreign key columns actually define some kind of relationship between the tables, right? So for that one, it is important. No uniqueness. So foreign keys don't need to be unique. The point which I was highlighting. So this is the simple example for you. I mean, I have already explained it with the employee and department, but you can quickly see the same thing. So we have a customer table. Here we have a customer ID as a primary key of this table, 1, 2, 3, 4. And we also have a order ID table, right? So in the order ID table, right? So customer can do what customers can do, they can place the orders, right? Okay, and one customer can place multiple orders, but individual order will have a unique ID, individual order ID. So this is our order table. You can see order ID is a primary key, 1, 2, 3, 4, 5, 6, and same customer, right? The customer ID 2, he basically placed two orders, maybe on a different time stamp on different dates basically. So 13th September, 13th October. So this customer placed two different orders and we are maintaining entry for that one in this order table. So this is the foreign key here. All right. So now let's look at the example part of it and try to implement it. But before that, let's take a 3-4 minute of a short break and then we'll come back and we will start with the referential integrity part and implementing primary key and foreign keys. So right now it's 10:09. Let's meet at 10:13 or so. All right. Let's get started. Cool. Okay. So we have talked about the primary keys. Let's see how we actually declare it, the syntax, and try to play around it. And then we will look into the foreign keys as well. So what I'm going to do, I'm going to create a new table. And here you will see the syntax of it, creating the primary key. So you can see I'm going to create a new table named as the persons. Okay. Just a moment. Yes. Mm. Okay. Right. So this is the table I am creating here. I have a ID as an integer column, name as a varchar, age as an integer. And now this is the simple way of defining the, you can say simple way of defining the primary key, that I have this particular column and I want to make it like a primary key. So the way you were maybe creating the unique constraint. So similarly, the constraint name is primary key and then ID. So this is one way of defining the constraint as I was saying, right? And maybe if I remove this thing, right, and put it like this is much more better way to define the, you can say, primary key constraint. So here, same thing, constraint name is PK, and then we are mentioning primary key and ID column is going to be our primary key. Okay. So now let's just create this one. So table is created. Let's refresh it a bit. Columns, right? All these things are created. Now this table is created and let's try to insert some record into it. So this is the first record I'm inserting. So you can see the first statement is successful. And now what will happen to this record if I'm trying to insert this one? It will throw the error, right? Most of you are saying this. So let's run this and see. So seems like you all are correct. And we have got this error, duplicate entry 1 for this key, persons.primary. So this is what we are getting, right? That some kind of a duplicate entry is getting created. That's why this is failing. Okay. And now try to do this thing. What we have. What will happen with this one? If I'm trying to do this, insert into persons values, this will also fail. The reason is primary key. We are trying to insert null value in the primary key column. And the definition of primary key is that it cannot contain basically the null values. So if I run this thing, you can see it is failing. So what it says, column ID cannot be null because it has been declared as a primary key. Okay. And now let's look into this part and let's create our demo for the referential integrity, right? And referential integrity basically, and along with that, the foreign key part, right? So we will replicate this example itself, sort of where we have the customers table and the orders table. So we will try to replicate the similar thing and we will try to check what happens here. Okay. So let's first create the customer table. So you can see we have a customer table. So customer ID as integer, name varchar, age integer. And here we have a constraint primary key, constraint name primary key, customer ID we are defining as a primary key. Okay. So let's execute it. It is done. And now after that, what we will do here, we will try to create the orders table. And as per this example, you can see orders table somehow containing the order ID and some type of reference we need to create so that this column can point to this primary key column. Okay. So let's look at this thing. So you can see, right, this is our orders table. And this is the part where we need to define and we need to set up our foreign key plus this foreign key setup, right? Or the reference will basically create the referential integrity as well. So we have the orders table. Here we have the order ID, order number, and the customer ID. So one thing is clear as per this example that order ID, this has to be unique because order ID, right? Even if a same person is placing two orders, right? Each order will have a different order ID, correct? So in the orders table, order ID is something we have to declare like the primary key. So constraint PK primary key order ID. So order ID is going to be the primary key of orders table. Then we have the order number. Let's give a better name to it. Order ID, order number. Let's give it a better number. Let me give it a date. Okay. Right. So order ID, order date, and then customer ID. So here, as per this example itself, the values which are coming in the customer ID column, somehow they belong to, or they are the values which are kind of the values of the primary key column here, right? So here, what we need to do, we need to set up this referential integrity that order in the orders table, customer ID, right? In the orders table, we have created one customer ID column. So it should be tightly coupled with the customer ID column of the customer table. Means some sort of reference we need to create here. Okay. So how we are giving this kind of syntax and reference? So constraint name is FK means foreign key. Foreign key means this customer ID column of the orders table, we want to declare it as a foreign key. And since it is a foreign key, means it has to refer something. Okay. So constraint FK foreign key customer ID. References means this customer ID, which particular column it should reference. References customer table. You can see customer table we have mentioned and cust underscore ID. Right? So this is how we are basically creating all the references and we are declaring our foreign key, right? And now you will basically see that how this referential integrity is helping us to maintain the, you can say to maintain the data consistency part. Okay. So let's execute this one. So this one is executed. So let's try to insert some values. First, we will try to insert some value here. So this is we are inserting in the customers table. So that is done. And apart from that, I will insert some values here. So one and date, let's say 2024 05 and 20. Right. So this is how we are inserting. So as I said earlier, the foreign key column can contain the duplicate values. It can also contain the null values, because here foreign key is just like another normal column of orders table, but somehow it is pointing to the another primary key column. So it does not mean that this customer ID column has also become the primary key of orders table. No, it is the foreign key, means just having some references, but still it is like another normal column of the orders table. Okay, so let's execute it. So all these three records are inserted. Let's quickly run the select star from customers. Oh, customer table. So you can see we have these records 1 and 2, and similarly for orders. So we have these records in the order table. All right, now let's run this, and you all need to tell me what is going to happen. So if I'm going to run this command, you all need to tell me what is going to happen. Again, you all are saying error. Give me the one line reason as well, right? Why the error is here. Right. So most of you are, so customer ID unknown. No, that is not the error you will be getting, right? So see, point is, when we maintain this referential integrity, right? What was the reason of declaring customer ID column as a foreign key? And it is referring this particular column, right? In this table. So right now, how many entries we have created in the customer table? Customer ID 1, customer ID 2. So when we executed these insert command, so here the customer ID's value were 1 and 2, which are already present in the customer table for the customer ID column. But in this record, can you see that you are trying to refer the customer ID value 5? Does it exist in this customer table? Like the value, any value related to customer ID 5, does it exist in the customer table? Absolutely not. So when it does not exist, and since you have tightly coupled this column, with the customer table, so obviously it is violating this. Means in the insert command, we are putting that kind of value which is still not present in the main table or main parent table. Hence, it is violating the foreign key constraint. And this is how you will be able to maintain this tightly coupled integrity, that unnecessary, there should not be any data discrepancy. Means some value is not present there, but still we are putting it in our data set, right? So whatever we have said so far, let's try to verify it. So we have executed it, and you can see at the bottom that it is failed. And let me show you the error response for the same. You can see cannot add or update a child row. A foreign key constraint fails, right? This one cannot update. So foreign key constraint fails. The only reason for that one is you are trying to refer such type of value which is not present in the parent table, right? So that is why we are getting this error. Okay, and all right. So one more thing we will try to do here. So this is the main thing I wanted to show you, because main referential integrity is like that. And I am trying to do this thing as well. Let's say, oh, drop truncate, my bad. Drop table, customer name. So one thing I want to ask here. So I have two tables, customer table, orders table. And now I want to drop this table, drop table customer, but you can see, right? I am getting this error, right? Why it is not allowing me to delete the customer table? It is giving me the error, right? So that is correct, because the reason is you have a customer table and you have referenced it in the orders table for the foreign key. And now if you are trying to delete this one, you are trying to drop this one, means, right, this is more like when you have a folder and inside that one you have created multiple folders. So sometimes what happens when you try to delete the main folder, it gives you the error that there are some files inside that folder. So it is similar to that one, because this is the hierarchy. Here this is your you can say this is your order table, right, where you have referenced this customer table. So if you are trying to delete or you are trying to drop this one, you will be getting the error that this table is getting referenced somewhere. So first you have to either disconnect that reference, means with the help of alter command, you need to simply delete this foreign key constraint, and then you will be able to drop the customer table. Else, the only way, first you need to drop the orders table, because once you drop the orders table, automatically this foreign key constraint will go away, and then you can drop the customer table as well. But obviously, why I would like to drop the orders table, just to manage this integrity, right? If I want this one, I will use the alter command. I will drop this foreign key constraint, and then I can easily simply delete the or drop the customer table command. That's it. Okay, cool. Now let's quickly, now we will basically moving towards the DQL part, means let's try to see the operations with the select command, right? Select command operations, and what sort of different functions we can use with the select command. Also, we will look at the update part, where clause, and logical operations like operation, auto increment. This is what we are going to cover next, one by one. So for that one, I will create the employee table one more time. And let's drop the employee table if it exists. We will create a new one. We will insert new record, and then we will try to see different operations of the select. So this is the table I'm creating, and then I'm inserting these records. So I have inserted all these records. Now, specifically looking for the select command. Okay. So here, let's say we want to, I mean, this is what we are doing. But again, I am reiterating on it. Let's say you have a table and you want to see all, you basically want to see all the columns of it in the output. So what you can do, you can run the select star from the employee. So select star basically represents every single column of a particular table, right? So this is how the select command works. You can see all the columns we are getting in the output. But by any chance in your select statement, if you want to if you are interested in just few columns, right? If you are interested in just few columns, then this is how you can write your select command. So instead of star, what you need to do, you need to put the comma separated column names. So when you run this type of select command in your final output, you will be only getting those number of columns in the output. Okay, so let's execute it. And here you can see in the final output, what you are getting name, salary, these two things, right? So sometimes what happens that I am in the table, right? The column names might be little bit technical or might be in such a way that not uh, they are not that much good to represent in front of a user, right? Or we would like to give the output with the different kind of name, different kind of uh, different type of name, right? So in that case, what we would like to do, we would like to change the name of our output columns. So here, what we will do, we can make a use of as alias, right? So we can basically give the alias name to the our final columns. So how we can do that and how to create the aliases. So this is what we will look at. So you can see here that in this previous command, select name comma salary from employee. So directly we got name and salary as a output. But now what we want to do, we want to give a different name to these columns while uh, giving or while returning them in the final result. So how we can give a different name or the alias name. So for that one, we can make a use of as keyword. So name as employee name, salary column as employee salary, right? So this is what we want to do. So let's run this one. And here in your final output, you can see you are getting the new output with the new column names like the employee name, employee salary. So this is what you are getting in the final output, right? Don't think that if you are making name as employee name, then these changes are going to happen in the table structure. No, this is just like a changes for the result you are giving to the user. Okay, so it is like that one. Cool. Now, let's say you have a data set and you want to check how many rows you have, right? How many rows you basically have in that particular data set. So here we can call the function as well, right? We can make a use of inbuilt function. And today we will be looking at the functions part as well, inbuilt functions and the user defined functions. So we'll look at that example as well. But here we can make a use of inbuilt function count. If we want to count how many total records are there, right? So how we can do that? We can make a use of this one. Okay. So select count star from employee, and I can give a this one as, let's say, total row count. I am giving a alias name to it, total row count. Okay. So I'm using the count function, which is inbuilt. So now here I'm running in your output, you can see total row 5. Okay. Now with this one, I also got idea for one more interview question, which is nothing, just sort of a, you can say bluff question, or again, you can consider it like a ice breaking question, whatever it is. Okay. You would have seen it maybe. right? So you might have seen or you may encounter this type of interview question sometime as well, that what is the difference between count star, count one, and even I can write here count ABC, count two, count five, count anything, right? So this kind of a question you can get. So my answer for this one, no difference. No difference in terms of performance, no difference in terms of output, no difference in terms of any optimization or anything, right? This is just like a trick question or nothing, but we need to understand the theory behind it, that when you run the count star, when you run the count one, what actually happens behind the scenes. Okay. So for that one, the idea is very much simple. Okay. So let's say this is our table, employee table, as I said. Okay. So column one, column two, column three, column four, and this is our row one, row, row two, row three, row four. Okay. So whenever you run this thing, right? Let's say you are running this count star part. Okay. So in the backend, what happens? The SQL engine, it basically try to put up this particular symbol or whatever you are passing inside the parenthesis, right? It uses this symbol just like a marker, right? And it basically put this symbol as a marker in front of each row. And what it does, it basically try to count only these markers, and that is the total count it return as a final output, right? And similarly, if you are doing, let's say, count one, so what it does here, it will put one, 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 one as a marker, and it will simply count all the ones, right? And will simply return that thing as a output. That is the only difference between this thing. So there is nothing like a optimization or anything. Just a marker. Okay. I hope if someone will ask you this question, you won't get confused anytime. All right, let's continue. Cool. So now one more, like, so here I'm giving you the few very basic and most frequent use functions. So for an example, one more operation we do very frequently. Let's say we have a column and we basically try to check how many distinct values are there, or we try to count how many distinct values are there, right? So this is what we are trying to do here, or we will try to do that, how many total rows are there or how many distinct values are there. So for our data set, if we run it on employee, let's say, so select star from employee. Okay. So here you can see we have, specifically if we are looking at the hiring date column. So we have 10th of August, right? And 11th of August and 12th. So in total, if you want to see, you have ultimately 3 distinct hiring dates you have, right? So let's say you want to check how many distinct hiring date values we have. So for that one, you can make a use of the distinct function, right? So distinct function can be used for this one. So how here the simple query which we want to solve. So print unique hiring dates from the employee table when employees joined it. So how our query is gonna look like? So our query is pretty much straightforward. right? Select. Here what we are doing, we are applying the distinct function on the hiring date column, right? And we are giving this thing a new alias name, means whatever output will be generated by this thing, we are giving a new alias or a new alias column name, which is distinct hiring dates. And let's try to run it. So here in the final output, you can see it is giving us the distinct values like 10th August, 11th August, and the 12th August. Okay. Now, let's say you want to modify this problem statement. Instead of the total distinct values individually, you want to get the count of it. Okay. So count of it, how you can do that? So as soon as you, let's say, applied the distinct function on this hiring date, so it became like another table for you, which is only having one column, which is like this, and only 3 rows. So if I have to count how many distinct values are there, so first I have already applied this distinct function on this one, and I can pass this intermediate output to the count function, and our count function will simply return the count of it. Okay, so let's do that. So here we will apply it on the, let's say, age column, because age was also duplicated. Right. So let me execute it and show you. So here in the age, you can see, right, 24, 25, 22, 25 again repeated, then 26. So there are duplicate values. Here the query is how many unique age values in the table. So you can see what I'm doing here. So first I applied the date. First I applied the distinct function on age column. So it will return us that output which we are passing in the count function, and whatever result we are getting, we are giving a name like total unique ages, and from this one, so let's execute it. And here we are getting total unique age. So there was 24, 25, 20, and 26. So 4 distinct values as a count we are getting here. Okay. So that is the example for very basic operation. Now, your question could be, can we only just select the columns in our final select statement, or we can do more than that? So definitely we can do more than that. So for an example, we, right. So for an example, we have this thing, right? So let's run this one and let me see what we have here. Do we have any salary column? Okay, yes, we have. Yeah, so here, what we will try to do, let's say we need to give a manipulated output to the user. The problem statement, let's say, increment the salary of each employee by 20% and display the final result with a new salary, right? So this is the kind of problem, let's say, we need to solve. Right? So problem is very basic. Increment salary of each employee by 20% and display final result with new salary. Okay. So means here we need to do some kind of calculation on the salary column and then display it as a new salary. And that calculation is nothing, means just multiply your salary by 1.2, or what the, like, whatever mathematical computation you want to do for the for adding or for incrementing the salary by the 20%. So if I have a salary, I simply multiply it with your 1.2, right? That is what we are going to get here, right, as a new salary. Okay, so how we are going to do that? Let's look at it. So you can see this is the kind of select operation we will be doing, right? So ID, name column, And here, how I want to display the information. I want to first create one column, which will be my salary column, and I will give a alias name as a old salary, right? And second thing, what I wanted to do, I wanted to generate one more column named as new salary. That new salary will be what? It will be 20% of my existing salary. Like more, like add the 20% part to it. So here you can see in my select statement, I am not just selecting the column, but I can do other operations as well. Moving forward, you will see complex queries where within the select statement, we are writing another nested query. We are applying the case when statement, right? We are doing few more complex stuff. So in the select statement or in your final output statement, you can definitely do these type of manipulations as well. All right. Because every calculation manipulation you are doing, it will become like a new column for the user, and you can even give a new alias name to that one. So let's run it. So you can see here our final output, old salary and new salary, which is like incremented by the 20%. Okay. Now let's try to look at another example, right? And that example is basically the update command, right? That if we have a data set, then how we can basically, so far we have seen the insert command, right? And create table, alter table. But if we have the existing data set, then how we can basically update the values inside that one. This is what we will be looking at now. Okay. So let me first show you the syntax for it. So for the update command, syntax is pretty much simple. Right, so syntax is update then table name, then set column name equals to value, comma, another column 2 equals to value 2, and so on, right? So this is how the syntax for the update command is going to look like, because we would like to update the particular table with and the existing records in the particular table with some sort of new values, right? So this is what we will be trying to do. So first statement, let's say we have this thing, right? Syntax, very simple syntax we will be following just to show you. Select star from the employee. Right, so this is the data set we have. Okay, so here on top of this one, I want to run the update command. So first update command, what I'm just going to run for the simplicity. So here in this operation, what we did in this operation, in our final select statement, we were just giving the new salary. But let's say this is our table, and since this is our table, so what ideally we should do? The salary of employee has been increased by the 20%. So we should update the salary and we should put the new salary values here. And new salary value is 20% extra of the existing value. So we need to basically update this salary column. So how we can run this query? That is what we will be looking at. So problem statement is simple. As I said, update the salary of employee after giving 20% increment. Okay. So in this case, we will be following a very simple approach, that is update. And after that, the keyword we need to provide our table name, means we want to update the employee table, and set keywords, because when you are updating means you are just giving new values, right, to some specific columns which you will write here. So update employee set means the next values and the column names I am going to provide after the set, those will be the new values. Okay. So update employee set, and what we want to change or what we want to modify here, we want to modify the salary column. And what will be the new value of the salary column? The new value of salary will be salary into 1.2, right? Means 20% increment. So ultimately, I'm multiplying it with 1.2. Okay. So this is what we have done. Let's execute it. And currently you can see here, right? This output, salary 10,000, 20,000, etc., is already given. So let's execute it. So we have ran it and the update command is successful. And after this, if I run this select command, so you can see updated values. So earlier for Shashank, the salary was 10,000. And after giving the 20% hike, obviously it will become 12,000, right? So similarly, other salaries have been incremented by 20%, and everything has been, you can say everything has been updated as per our update statement, which we have executed here. Okay. So now this is the update statement, and maybe if you want to update, if you basically wanted to update more than one values, right, in one single update statement, then how that can be done? This is the example we will also look at. So for an example, we are giving this, this is just like a random example I'm giving. So here we are going to do two updates here. For an example, update the salary of employee after giving 20%, and change the age and make it constant value 25 for each row, right? So two updates together we want to do that. Salary column is something, again we are giving, let's say 20%, or maybe this time 30%, increment we want to give, and that salary should be updated in the final table. Apart from that, for each employee, the value of age should be equals to 25, right? So this is the kind of update query we want to write. So update employee set, this time salary equals to salary into 1.3, because 30%, and comma separated another update statement for which particular column we want to apply, age equals to 25, right? So here you can see in one single statement, I am trying to update more than one column's value with a different logic. So if I run this thing now, let's run it. So update is successful. And now if I run the select command, so here you will see the age column is containing 25, 25, 25 for everyone, and new salary has become the like another 30% increment on top of previous 20% increment. Okay, so this is how we can even update more than one columns with one single update statement. Okay. Now let's try to look into this filter command. right? Let's try to look into the filter command and or basically you can say the where clause, right? So where clause in the SQL is basically used to filter out the result, right, from any particular table, or to apply some sort of filter on a particular table. We use the where clause. Okay. So let's look at the example for it. So imagine this is our you can say data set, and here what kind of data we would like to filter. So get all the employees who are earning more than 15, or not 15, 15,000, right? So this is the kind of query we need to write. Means we want the data of all such employees who are earning the and whose salary is more than 20,000. Simple. Okay. So even the problem statement sounds like that we need to apply some kind of filter condition, right? And in SQL, to apply filter condition, we need to make a use of the where clause. So here, this is what we will be doing. So let's write the query for it. So select star from our employee table, and then how the syntax goes, select star from employee where. So that is why we call it as a where clause. So where salary, right? Salary greater than 20,000, right? So this is the kind of simple where clause we have written, like select star from employee where salary is greater than 20,000. Okay. So let's execute this query and see the output. So here you can see our final output, only 2 records we are getting. So Rahul and Puneet, these two are the folks who are earning more than 20,000 a month. So in this way, we are simply able to apply the where clause. Okay, or you can see the filter condition. So now in the previous example of update query, right? In the previous example of update query, there what we did, when we applied the update statement, it basically changed the data for every single row present in the table, right? But what about those scenarios where we want to update the value for very specific rows? So obviously in that scenario, we need to apply some filter condition while even updating the data set, right? So that is the reason we will be making a use of the where clause along with our update statement to achieve the same thing. Okay. So here the simple query which we need to solve here, and maybe you can also try to do that, right? You can quickly do that because now you know how to do the where statement, or maybe let me solve it for you. Not an issue. I will give you another problem to solve today. So here the question is update the salary of employees who joined the company on 10th of August, right? Or this way, update the salary of employees to 80,000 who joined the company on 10th of August. Means let's say they are someone who have completed 3 years, 4 years of anniversary. So we are giving the 80,000 salary. We are just updating their salary to 80,000 something. Okay. So in this case, you can see, right, this is going to be a very selective update for us. Okay. So how we basically do this thing here, update employee, and what we want to do here, we want to set the value of salary column, right? So update employee set salary equals to 80,000, right? This is the new value of salary column we want to make. But if we only do this part, this change will be applied for every single row. But how we want to do it? Update employee set salary equals to 80,000 only for those rows where hiring date is 10th of August. Means where hiring date equals to 10th of August, right? So this is how we are doing a restricted update or very selective update. So let's run this one. This update is successful. And here, let's run the select query to see the same. So now here you can see these were the two employees like Shashank, Rahul, who joined the company on 10th of August, and only their salary was updated to 80,000. Rest other records are intact and no changes for that one. Okay. So that was the update statement with the filter. Cool. Now, previously we looked at the drop command and truncate command, right? And on top of it, we had this thing as well, right? So delete command. So the delete command, I told you that if you want to delete very selective records or based on some conditional record, right? So now this is the right time to show you the syntax for the delete as well, that how we can delete the data based on the some specific condition, right? So for that one, what kind of query we are going to solve? Delete the records of those employees who joined the companies on 10th of August, right? So let's say now these two guys who or all the employees who joined on 10th of August may have left the current company. So obviously we would like to delete their records from the database. Okay. So if you look at the syntax of delete, how it looks like, because here this might sound very similar to select star from. So sometimes, right, even in the beginning I have also made mistake, like I tried to put delete star from then the entire condition. Okay, so very common and basic mistake, but the main syntax of delete is this one, delete from, because there is no star or something, you are deleting the entire row, so putting a star or anything does not even make sense. So delete from table name and whatever where condition you want to put up, right? So here delete record of those employees who join company on this condition. So how we are going to write this query? This way. So delete from our table name where hiring date equals to this, correct? So in this way, we are going to delete the selective records only. So let's run this one. So this is done. And now if I run this select query, so here you will see only these three records are present in the table and rest those two are deleted now. Okay. So let's take a 2-3 minutes of break. Let's meet at 11:10 and then we will continue with other part like the auto increment and the like functions and the main functions part. So let's meet at 11:10. All right, let's get started. Cool. Let's move ahead. Uh, okay. So since we were talking about the primary keys, and one of the thing which I mentioned there, that is the like we always try to choose some ID type of columns, as in which are incrementing till a very large value, right? Or every time there should be a new value for that one. So what is that one common method that I want to create a table, right? And I want to have a particular column there with the some ID, and I want to use it as a primary key. But I don't want to insert a new and unique value every time. Okay. So in that case, how that can be done? So here we can actually leverage the auto increment part, right? That is one of the thing which we can declare during the create table part itself. So there is a keyword which we can use, auto increment. So in that case, what will happen? Doesn't matter if you are providing any value for it. And obviously, if you have, sorry, define it as a auto increment, then there is no need to provide the value for it. Every time you are inserting a new row, automatically value will just incremented by one for that one, and it will start from the one. Okay. So let me show you just this a small example for that one, that how you can leverage this thing. So for that one, I will be creating a dummy table. So you can see I am creating a dummy table here, create table, auto increment example. And here what I have done, I have one ID column, which is of integer type. And in front of that, I have mentioned this auto underscore increment keyword. So putting this keyword means I don't need to provide any value moving forward in my insert statements. I will only provide value for the name column, and what will happen every time a new row is getting inserted, the value of ID will keep on incremented by one. Okay. So we will see that with an example as well. So let's first create this table. So I have created it now, and let's insert one value first and see what we are going to get. Okay. So here we have done that one, and select star from this one. So here you can see in this example, I only have this name column, right? And I'm only providing the value for name, but you can see the record which has been created in this one, right? I had two column, ID and name. The value for ID is one, already one. Okay. And now if I simply insert one more record into it, okay. So let's just run this one. I have executed it, and again let's run the select star. Now you can see Rahul was there and the value is 2 now. Okay. So in this way, like this auto increment functionality can be used, and right, because having or deciding about the primary key, like if you are creating a table right from the scratch and you want every record to be unique, there means you need to derive the unique values for every individual record. So ID column is something which can be leveraged here, and every time it will have a new incremented value. Okay. And now let's look at this part as well. So we have our what I should say, employee table. Select star from employee. Yes. Okay. So here, by any chance, when you are selecting the records, when you are selecting some result and you want some limited number of output, right? Let's say just 5 record, 10 record, 30 records, 40 records. So how to basically restrict those many number of records in my final output? So for that one, what we can do, we can make a use of limit, right? So we can simply make a use of limit, and in that way we will be able to get a very specific number of rows in our outcome, right? So limit can be used for that one, and it will have any integer number in front of it which defines the total number or the maximum rows, because there could be a scenario, let's say in your table there are only 100 records, but you have put the limit equals to 100. In your table you have 10 records, but in your limit you have put the 100 limit 100, but you will be getting only 10 records because this is the maximum you have in your table. But if you have 200 records in your table and you have put the limit as 100, then you will be getting the only 100 records from the starting. So here, if I ran the select star from employee, it is giving me all the outputs, all the records. And now if I'm running this thing, select star from employee limit 2, so I am only getting the 2 records, right? So this is how I can simply restrict the number of rows in the outcome, right? So that was the limit part. And before that, we covered the update, we covered the where clause. Now we will be covering one more important clause, because whenever it is all about to, what I should say, whenever it is all about to what I should say, yeah, whenever it is about to display the output in some specific order, right? Whenever it is all about to display the output in some specific order, then what we simply need to do, okay, then what we need to do, guys, what is this? I mean, I'm not sure, either you are focusing in the live class or you are focusing on creating tons of WhatsApp group, tons of Telegram groups. I mean, not sure what is your way of studying the things or leveraging the chat for this thing. This is the most silly conversation I can see as of now in the chat. WhatsApp group. I mean, what will you do with tens of WhatsApp group if you are not even focusing properly in the live class? What we are covering, what we are teaching. Such a stupid thing. Okay, so order by clause means this is something which will help us to arrange the data in some specific order, means some ascending order of the column, some descending order of the column. Okay, so this is what we will be using, and I will show you the different examples that how you can use the order by clause, how many you can say columns you can provide, multi-levels arrangement in the ascending and descending order. And we will try to solve like popular interview question as well by using the limit and order, and I will leave that question on you. You need to solve it. But first, let's see how you can use the order by to arrange your output in some descending and ascending order of a particular column. Cool. So for an example, we have this data, right? We have, let's say, 3 records here. Let's run this one. Okay. So we have this record, these many 3 records basically. Okay. So for an example, we want to get this data in the alphabetical order, right? When we are running the select statement, I want this data to be present in the alphabetical order. Ascending order means whenever you put your data in the alphabetical order, things starting from A, then will be B, C, something like this. So how we can do that and how we can write the order by clause? So select star from, or maybe I will quickly put it in this way instead of writing. So select star from the table and order by. This is the clause we need to use, order by clause, and we are putting the name here, name column. I want to order my data on the name column. So by default, when you give a particular column in the order by clause, so by default, it arrange your data in the ascending form, right? So the default nature is in the ascending form. Okay. So let me quickly run this one and let's quickly check the output. So here you can see, right? The data we are getting, it is in the ascending order of the name. So Amit, Puneet, Sunny, something like this. Okay. Cool. So that is the very basic example. Now let's say I want my data to be sorted in the descending order, right? So default nature, we all know that it will be sorting it in the ascending order, but how we can do it in the descending order? So for that one, it allows to provide a one more keyword after the column name, that is sorting type. So explicitly, if you want to sort it in the descending order, so DESC, right? Means descending, some short form of it we need to write. And once I run this thing, then you will see the change in your output. Now your output is arranged in the descending order of your name, descending order of the name column, like Sunny, Puneet, and Amit. Okay. So now here, this is what we are doing, name, descending order. So we have seen both of the option for ascending and descending. Now in this example, we have only applied the data, or we have only applied the order by clause on just one single column. But imagine a very big table which has multiple columns, and even when we are selecting few columns on which we want to apply the order by clause, there might be duplicates as well, right? Or we would like to do a multi-level sorting as well. Multi-level sorting means more than one columns, right? If we want that kind of arrangement, then how we can do that? Okay, so let's try to let's try to understand that example as well. Okay, so for this one, what example would be good? Yeah. So in this example, what I will try to do, I will try to put it in this way. Let's say I have this data. So what I want to do, I want to apply the multi-level sorting. Means the first level of sorting, I would like to apply on the hiring date. Okay. So means arrange my data. First, pick the hiring date column and arrange my data in the descending order, right? Means employees who joined latest, like till the oldest one, right? By any chance, if there are duplicate values, because that is possibility on which column you are applying the order by clause, right? You have the duplicate values for that one, 2, 3, 4, 5 values are duplicate. Then in that case, how you are going to arrange that data, right? Duplicate values, how you are going to arrange that data, or if you want further level of sorting, then how you can do that. So let's try to look at or understand it with the example, then it will make more sense to you. So the example we are seeing here, this one, hiring date. Okay. So select star from employee, order by, hiring date, descending, right? So order by, you can see, right? Comma separated, I am providing. For name column, either I can write ASC, means this is the notation for ascending. Either I can write it or I can skip it, because the default nature will be the ascending sorting. Okay. So here I am going to change little bit. So select star from employee, order by. So first column, I want first my data to be arranged on the descending order of hiring date. After that, I want my data to be arranged in the ascending order of salary, let's say, right? Ascending order of salary, let's say. So now let me just run this one and show you the output. Okay. So look at this part. Your data, if you look at the hiring date column, okay. So hiring date column, it has been sorted in the descending order, and these values are same. So since these values are same, means obviously during the sorting, all these duplicate values will be put together. And that is what we can see here. But whenever we have multiple records with the same value, in that case, we decided that I will be arranging these type of record where the second level of sorting will be on the salary column, right? This is going to be our second level of sorting, right? This is our second level of sorting whenever these duplicate values are coming into the picture. So you can see, right? 11th of August, 11th of August. These are two rows where the value of hiring date is same. When you are not, let's say you have not included this column, right? You have not even included this column in your order by for anything. You have only kept hiring date descending. So this is how you will simply get the data randomly. Either this row, means the row which is Sunny, named as Sunny, either it can be here or it can be at the bottom, right? Because both are containing the same value for hiring date. Randomly it will be generated. But here, how we are controlling it, because let's say any two particular row, more than two, are having the same hiring date, then I will be arranging those records or those particular rows in the descending order of the salary. And that is what you can see here. Sorry, ascending order of salary. And that is what you can see, that we have Sunny, and here salary is like this 17,000 because it is having the lesser salary than the 18,001. Got it? So this is how it is working here. Okay, so multi-level sorting is going to be work like that. So now I am giving you 1 minute. Okay, you don't need to use anything else, right? You only need to use the things which we have covered so far. No any other advanced level of, you can say, no any other advanced level of topic, right? So solve this query. Write a query to find the employee who is getting the maximum salary. I want only that employee's record in my final output. You have 1 minute to solve it and post your output in the chat. So first of all, whosoever is doing select max salary from employee, select max salary from employee, you are doing it wrong. Read the query again. Write a query to find the employee. I did not ask, give me the maximum salary. I am asking, give me that employee who is getting the maximum salary, right? So read the problem statement properly. Cool. I guess most of you are getting it right, that how to solve it. So you have used the correct thing, because we have the order by thing which can arrange our output on some specific ordering, and we also have the limit. So this is a very basic way or basic approach to solve it with the limit or something, right? So I just wanted you all to solve it. That's it. Okay. So how we are solving it? This is going to be the query. So first what we will do, select star from employee order by, right? And then what we are doing, salary, order by salary in the descending. Okay. So what will happen? First, our data will be arranged in the descending order of salary. And we wanted that employee who is getting the maximum salary. So I can simply apply the limit one. So I will be only getting the one record. And here you can assume that uh, each employee is getting the distinct salary. That's what I am saying. There will be few more scenarios we will be solving later on, that what if the salary, like 4 employees are getting the same salary and that is the maximum salary, which one to pick, which one to not. That will depend on the assumptions and the kind of output somebody is expecting. So we will discuss these things later, but here the idea was just like how you can solve it with the basics of order by and the limits. Okay. And this is something which is one of the most important interview question as well. You will definitely encounter here and there, not maybe sometimes employee, it could be something else. Maybe you have the orders data. So find the probably order who had the maximum amount, something, right? Or any other sort of scenario. So you can solve it with this basic approach as well. Okay, let me plug in my charger. All right. Cool. So now it's time to look at these things. I mean, very simple and very basic, nothing extraordinary here to understand. Uh, the conditional operators are a bit easy to understand, but still we will look at it. So these are the things we are going to look at now. So you are comfortable with where clause now, you know how to filter the data, filter the record. So we will be looking at how you can make a use of these conditional operators like the less than, greater than, less than equals to, greater than equals to, and also not equals to, right? Something, these type of things. And apart from the logical operators like and, or, not. Okay. So these are the kind of things we will be looking at with these examples. Okay. So yeah, let's look at this one. So very simple to apply here, right? So I will be putting all these examples quickly so that we will be executing it and you can understand it quickly. Okay. So greater than, right? Mostly these conditional operators you are and you will be using with the where clauses, where you are putting some sort of condition, right? That is why they are named as conditional operators. Like I want my data where this data should be filtered out based on this column with salary greater than 20,000, salary greater than equals to 20,000, right? Salary less than 20,000, less than equals to 20,000, right? So these are the conditional operators, right, where which can be used with any particular column. So here you can see we are getting this record, only Puneet is something who is earning salary greater than 20,000, greater than equals to, like along with the greater than we want to check the equality condition as well. And this is for the less than sign, right? Means if I want to find or want to filter all those records where the salary is less than the 20,000. And similarly, this is for the less than equals to 20,000. Okay. Apart from that, if we want to check the equality condition as well, right, that particular value should be, or we want to filter out those records where the value is equals to some specific column value is equals to some specific value. So these type of things we already have seen in the example, I guess, right? So this is how the equality condition will be applied, as you can see in the where clause, right? Or let me put it in this way as well. So here, let's say filter the record where age of employees is equals to 20, 25 or something, right? So select star from employee where age equals to 20. So this is our equality condition. This is what we are putting, right? And next is not equals to, right? Not equals to kind of condition, how we can check that. So for that one, we can put this type of condition, right? This type of operator we can use. So select star from employee where age not equals to 20, right? Where age is not equals to 20. So here, what you will see basically, select star from employee where age not equals to 20. You can see we are using this type of operator. Okay. So now if I run this one and execute it, you are getting all the records where age is not equals to 20 because age is 25. There is one more syntax for the not equality condition, which is this one, the double closed cap signs, right? So this is also like you can either use this or this one. Both represents the not equals to kind of approach. So whenever in some queries you see this type of operator getting used, so don't get confused. It is basically for the not equality type of comparison. So if you run this one, right, you will getting the same output where age is not equals to 25. So both are same, this one and this one. Okay. Now quickly look at this part where we have this thing, what I should say. Yeah, the and or type of conditions, the logical conditions, how we are going to use it. So for an example, we want to filter out this thing. Okay. So and condition means whenever you are writing some conditional statements, right? Whenever you are trying to write the conditional statements, how you can basically filter them, right? And where you can add more than one conditions with these logical operators, right? So and operator, we know that means if there are multiple conditions who are attached with and, so all of them have to be true. Only in that case it will satisfy the condition and we will be getting the output, right? So in this query you can see here what we are trying to do. Select a star from employee where hiring date is this one, like 11th of August, right? And salary, let's say we can put it 20,000, less than 20,000. Okay. So this is the kind of condition we are writing here, means I would like to filter all those employees, right, who basically joined the company on 11th of August and having the salaries less than 20,000, right? So here, in order to get the correct output, and since our problem statement is like that, we need to check these hard conditions, right? Means each record, when both of those conditions, right, this one and this one will be satisfied by that particular record, only then we will be getting these type of records in the final output. Else we will be getting empty output if any of the condition is breaking. That is basically our and part, right? So logical and, this is how it works. Both left hand side, right hand side, both has to be true. Then we will be getting the output. So let's run it. And you can see these were the two records where the hiring date was 11th of August and both of these salaries are actually less than 20,000. That is why we are only getting these two records in our final output. Okay, now let's look at another example as well. Right. So another example is this one. With so here we looked at the and logical operator. Here we will be looking at the or logical operator. So select star from employee where hiring date is greater than the 11th of August, means 12th of August, 13th of August and anything but after 11th of August, right? So in our final output, we will be picking that record if the hiring date is greater than 11, either this condition is true. If this condition is true, right, for any record, then this condition will not be checked, because here we are using the OR operation. So OR means either this is satisfied or this is satisfied. Any of it is satisfying the condition, means that record will be picked in the final output. Okay, so let's try to run this condition. Let's see what happens with the OR part. So here we are getting all three records. The reason is, let's try to identify. So let's say my query cursor currently on this row. So here, if you try to look at this condition, hiring date is greater than 11 of August. So this condition is not getting satisfied, because here we are checking the greater than condition, and here the hiring date is exactly 11th of August. So this condition is failing. Since this condition failed, it will move to the next condition. Next condition is salary less than 20,000. So here salary is definitely less than 20,000. That's why this record has satisfied this condition connected with OR logical operator. That is why this row has been picked in the final output. Same thing applies for this one. Here, hiring date condition is not getting satisfied, but the salary condition is getting satisfied. That is why we are getting this record in the output. Look at the third one. Here, you can see hiring date greater than 11th of August. Yes, hiring date is greater than 11th of August. And as I said, right, whenever you work with the and or these kind of logical statements, there is a concept of short circuiting, right? Short circuiting, what it means, right? The operations will start evaluating from the left hand side by any time. If a condition is satisfied, right? There, like, as soon as the condition is satisfied, all the operations or expressions written after that one will not be executed, because there is no point to execute it. At this point, my condition is already satisfied. Why I will go here to compare this condition, right? There is no need of it, because we have a OR condition. So this is a short circuiting. Similarly, here for the AND part, let's say any condition is failing at this point. Hiring date is not equals to this one. And since we have used the AND operation, means this and this both has to be true. And by any chance, if this is failing, means there is no point to check this condition, because ultimately my end result is going to be false. So that is how your AND and OR conditions are going to work, and you can use it in your where clauses. You can make the conditions more and more complex, like you can add AND condition or conditions together, and you can work in that way, right? And let's look at one more example, and that example is related to the between operation, right? So whenever we have to do a range based comparison, right, or whenever we want to apply a filter condition, and where we want to check a particular column value lies between this lower limit and upper limit, there we can use the between operation, right? And it will be used with the where clause always, not with any other else, but where clause. So, right, so let's try to see how we can see that one. So here I am writing our like I want to write a query that give me the list of all such employees who joined the companies between 5th of August to 11th of August, right? Who joined the company from basically 5th of August to 11th of August, inclusive window, right? 5th of August will be also included. 11th of August will be also included. Okay, I only want that one. Okay, so Let's write the query for it and let's see the syntax. So this is how the syntax will look like. Select star from employee where hiring date, and here, as I said, right, we are trying to do a range based comparison. So our lower limit was 5th of August. Upper limit was 11th of August. So I want to check hiring date, means with this expression, any record where hiring date is lying between these two values will be selected in our final output. So where hiring date between 5th of August and 11th of August. So let's run this one. And you can see these two records in our final output, because as I said, this and this value is also inclusive. It does not mean when we are saying 5 to 11, so it will only check for the 6th of August to 10th of August. No, it will not check only for in between. It will check the equality condition for this date and for this date as well. Right? Let's say we want to do it for other as well, right? For an example, this example was for the date column, but let's say I want to apply the similar kind of approach for salary kind of column as well. Means I want to fetch the record of those employees who are getting salaries between, let's say, 18,000 to 30,000. Okay. So I want to fetch all such type of employees who are getting the salary between the 18,000 to the 30,000. So this is how I am using it. I have applied this between operation with the salary column. So I am checking salary should be between 18,000 to 30,000. So let's run it. And here I am only getting one record, because this value 18,720 lies between this and this value. Hence we are getting only one record. And this is how we can get the final output. Cool. So now let's move on to the next. And that is also one more, one of the important, I would say, operation specifically for the string type of columns, right? So just like other programming languages or just like other normal use cases, let's say you have a particular string column and you want to do some pattern based searching, right? So pattern based searching, what does it mean? That I have a string column and I will be checking if this particular string is following this kind of pattern, then I would like to fetch all such type of rows, right? So this is more like a regex, regular expressions. So how we do it in the MySQL queries, for that one, we will be using the like operation. Okay. And that is something which will be mostly used with your where clause, because it is giving you some filtered values. Means you have a pattern and you have a string and you want to check whether this string follows this regex pattern or not. If yes, select it in my final output. Okay. So first let's quickly try to understand it from the